Hi guys, welcome to Python programming. Why should you learn Python? It is the most popular programming language and it's easy to learn because it uses human-like language. There are a lot of career opportunities in machine learning, artificial intelligence, data science, automation where you can solve difficult problems in less time, and also data analytics. You can use Python to build mobile apps and web applications. How to comment in Python? This is a comment. By using a hash symbol, it means we are commenting in Python. Hash symbol is used to comment. A comment can be used to prevent code from executing. In case we have this code, hash symbol in front of the code, the line of code, so it will not execute. In this case, we have our code. We've removed the comment, so when we hit the enter key, the code will output to the screen. It is not commented out. But also comments can be used to explain code. We can declare two variables, but we can explain about what this code is doing. So how to perform multiplication. We are using a comment here. We have two variables where x is assigned a value of 2 and y is assigned a value of 10. If someone reads, they'll be able to know what we're trying to do here. X multiplied by y, we use the asterisk symbol for multiplication in Python. What will be the result? The result is 20. Carrying on, comments also can help to improve readability. I'm going to introduce the print function. The print function allows us to output something to the screen. So let's print something to the screen. We use the parentheses, and I can use double quotes or single quotes inside the print function. So when you hit the enter key, the result is welcome to Python programming. When you have the input function, you have parentheses, then enclosed, then the message you want to display to the user, enclosed by either double quotes or single quotes. In this case, once you hit the enter key, you're going to have this message: enter your full name. Once the full name is entered, you can also print what this variable is holding, full name, by using the print function. There are so print full name. The result is John Doe. The input function always returns a string. To demonstrate that, let's find the data type of this variable full name. A string. So even when you enter a number, it will return a string. Let's demonstrate that. So to find a variable called age, and we'll allow it to hold the value we're going to enter. So in this case, I hold a year of 50. So age is holding the value 50. So when try to find the type of this value, we discover that it's a string because the input function always returns a string. But there is a way we can convert this number to an integer. So we can use the int function to convert the string to an integer. This is how you can combine the int function and the input function to convert to an integer. So you define a variable, we'll call my age, and then enclose the input function within the int function. So that whatever you're going to enter this time around, this is type int. We're going to look at the comparison operators. We start by declaring three variables: age1, which is assigned a value of 20, age2 assigned a value of 30, age3 assigned an integer value of 20. Equal to checks if two values are equal. Strings can also be compared. So looking at an example, using the variables we have defined, So we're asking, is age 1 equal to age 2? The equal to has two equal signs next to each other, whereas the assignment operator is just one equal sign. Let's find out what the answer will be. So false, because these two values are not equal. Let's have another example. This time it's a string. If you want to compare these two string variables, if they are equal, put some quotes around them. These two equal? No, because Johnson is spelled with a capital J and the other Johnson is spelled with a lowercase j. Therefore, they are not equal. Let's carry on. Not equal to, I checks if two values are not equal. So we have age 1. Is age 1 not equal to age 3? Age 1 is 20, age 3 is... So the answer is, checks if two values are not equal. So false. Let's carry on with more examples. So we have less than, checks if the left value is less than the right value. Here we have is age 3 less than age 2. Age 3 is assigned a value of 20. Age 2 is assigned a value of 20. Output is true. So age 3, which is assigned a value of 20, is less than age 2 assigned a value of 30. It's true. Let's try another example. This time we're looking at the less than or equal to comparison operator, which checks if the left hand side is equal to or less than the right value. So is age 2 less than or equal to age 1? Age 2 is 30. Is 30 less than or equal to age 1, which is 20? The result is false. Let's carry on. The greater than checks if the left value is greater than the right value. So is h2 greater than h3? So in other words, is 30 greater than h3 20? Logical operators, and logical operators return a Boolean value depending on the type of inputs. Accepts two inputs, it can return a Boolean true or a Boolean false. We define two variables we defined are on assigned a value of true and not on assigned a value of false. We look at the logical AND operator, the AND operator. According to the definition, the logical AND operator returns the Boolean true if both inputs are true. So when we have on and on, which is true and true, it's true because both inputs are true. When we try on and not on, we expect a false because we have one input which is false. That is false and false. What do we get? False, because both inputs are false. We try again, not on and on. Not on is false, on is true. The result should be false because one input is false and the other input is true. Then we go to another logical operator, the OR. The OR operator returns the Boolean true if at least one of the inputs is true. We use the same variables we declared earlier. So we have on or on, both inputs are true, so it's at least one of the inputs is true, so it's true. So we try again, on, which is true, or not on, which is false. So at least one of the inputs is true, we should expect an output of true. Then carrying on, we have not on or not on. Both inputs are false, so what should we expect? False. Then not on or on, true. So let's look at another operator, the not logical operator versus the input. What is not on? On is true. What is not true? Let's see the output. False. So this is basically a highlight of the logical operators. There are rules to name variables in Python, and one of those rules is that when naming variables, do not use Python keywords like class, def, print, in, or and. Let's look at an example. We are going to define a variable by using a Python keyword. So when you run the program, it says there's a syntax error. And then the second rule is that do not start with a number when naming a variable in Python. When you try to do that, the program will generate an error. In this case, we have 2 in front of the variable name, and then we get a syntax error. Then variable names are case sensitive. When you declare a variable called age, then try to print age with a capital, you'll get an error. This is the error you get. Age is not defined because the age you have is the lowercase a, starts with the lowercase a, then the age you're trying to print capitalized. If you want to find out why this is so, the odd function can be used to retrieve the ASCII value of the keyboard character. Look at the values of capital A and the values of lowercase a in Python. So when you try to print the value of lowercase a, you find that the computer looks at the lowercase a as an integer, and then it also looks at the uppercase e as 65. So that's why you see that you're getting this error, because this uppercase a is different from the lowercase a. When you want to define a variable correctly, you can use letters, underscores, numbers, and also you can also start with an underscore, you can end with an underscore. Let's look at examples. All these are valid variable names. All these are defining valid variable names. The int type supports basic arithmetic operations such as addition, subtraction, division, multiplication, modulus, and exponentiation. Let's declare 2 variables to demonstrate this, where x is assigned a value of 15 and y is assigned a value of 2. What is x plus y? 17. And what is x minus y? 13. What is x divided by y? 7.5. What's the remainder when you divide x by y? The remainder is 1. So this is the modulus. It allows you to calculate the remainder. In Python, the numeric type comprises int, the float type, and the complex type. We demonstrate the float type. These float type are numbers with a decimal point. So we declare a variable called price and assign a value of 10.99 and the quantity where we assign a value of 12. The float type can also perform some basic arithmetic operation. We want to calculate the total cost. We multiply the price by the quantity, which is equal to. The float function can be used to convert another type to float. We perform an example where we accept user input. In this case, so the user is asked to enter the price of 1 cookie. So the price of 1 cookie is entered, and we convert that to float. So how much is 1 cookie? 12.99. How many cookies are you buying? 5. Calculate the total cost as the price multiplied by quantity. In this case, our total cost is equal to 64.95. And now we look at the complex type. So we declare the complex type this way, where we have 2 plus 3j. We use a j in Python, but in mathematics you find that there's an I that is used. And the way we tear this apart is that the 2 is the real part, and then the 3 is the imaginary part, and the j is the imaginary unit. This is equivalent to the square root of -1. Even print what we've declared to the screen, and also find what type this is, and then to just verify the type. Declaring string type. String type can be declared using the assignment operator, this symbol here. We declare a string called string 1, the variable. Strings can be indexed because each string in a string has a position. The first position is 0, just like in other programming language. When dealing with arrays, you find that the first position is 0. So let's declare a string called string to index. This string carries the value of programming. Index position 0 in this string. So we count starting from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we print, what do we get as an output? So P is occupying index position 0. Then what is occupying index number 3 is G. What's occupying index position number 10 is G again. You can index the characters within a string in Python. Strings can be sliced. That means that a substring can be retrieved from a given string. We declare a variable called slice me and assign a value of an unsliced. To slice this string, we use the square brackets and then the position, that's the index number from where I want the string to be printed. So in this case, we are printing this string from index number 0, which is this character U, and then a colon. Then we haven't put the other index number, so we'll print everything from index number 0 to the end of the string. The result is unsliced. Now let's look at another example. In this example, we're going to print all the strings from index number 2 to index number 7. So from 0, 1, so we'll print from this 2, 3, 4, 5, 6, 7. So what will be the result? Sliced. We carry on with the example. An empty space holds an index number within a string. So we define another string called a string with space here. What happens when we try to print this string? See, try to print a string holding index number 2. So it's an empty space. But the good example is this one where we have index position number 1 to 4. 1, 2, 3. There we print M, and also the space is shown that has been printed to the screen. So in this example here, see that nothing was printed because what's holding index number 2, so we start 0, 1, 2, it's a space, so the blank space was printed. This is how you can slice a string. There are a few methods that can be used to work with the string in Python. The count method returns a number of times a given value appears in the string. So we declare a variable called countMe and assign a value of programming. So we can use the count method to find out how many times the character M appears in this string programming. When we print, we'll find that we have 2 M characters in this word programming. Then we can also repeat the same example by this time demonstrating the number of times the word Python appears in this string. When you hit the enter key, you find that Python appears 3 times. 1, 2, 3. The strip method gets rid of spaces on both sides of the string. We declare a string called strip me, and we assign a variable here. We have spaces here in front of the string and at the end of the string. And when we try to use the strip method, what is the result? So to use the strip method, just we have this variable or name strip me, then a dot, and the strip method, so that we strip out these spaces. So what do we print? So when printed, we get here, we've stripped out the spaces. Print the original string with spaces and see the output. For the original string, there's a space here because we printed strip me. Len method to count the length of the string. This method counts the number of characters in a string. So we declare a string variable called string underscore 3 and assign a value of I am here. Then we apply the len method to string 3. Let's use the print function to see the result. The result shows that there are 7 characters, 1, 2, 3, 4, 5, 6, 7, including the spaces. The next method, the title method, which converts the first letter of each word to uppercase. Let's apply the title method to string 3. The first letter of each word is capitalized. The upper method converts the lowercase letters to uppercase. So we apply the upper method to string 3 and declare a new variable called upper string 3. Let's print the result and look at the output. Here we go. We have all the letters have been capitalized. Then we have the lower method, which converts the uppercase letters to lowercase. We apply the lower method to string 3 and give it a new variable called lower string 3. Printing the result is on here. So we've converted to lowercase letters. Then to convert a value to string, you can use the string method. So you type, you declare a number of which is an integer value and convert to string by using this value. You see that when you print, it's giving you the result of the converted value, which was, in this case, it was an integer. We assigned the converted value to this variable converted to string, which we are going to print out so that we see the type. We've converted it to type string. You can repeat a given string a number of times. You do this by declaring the string. We will declare a string called repeat me and assign a value of go. And then we want to repeat this string 4 times, but also use the asterisk symbol, which is also used for multiplication. So when we hit the enter key, we see that we've repeated the string 4 times. You can also use the concatenation feature to concatenate strings. The plus symbol is used to concatenate strings. This plus symbol. This is how you can achieve that. So we declare a string called name and another string called hometown. So to concatenate this string, we use the print function. So we're concatenating my name is, then by using the concatenation feature, I'll concatenate the name, a variable, and then I live in is also concatenated to the hometown variable. When we print the result, you're going to see that the result is my name is John Doe, I live in Chicago. There is also another way of doing that by using the format string, by using the f strings. The way you use the f strings in Python, you can do it within the print function by first putting an f in front of the uh, string you want to go to format. So my name is, and then the variable name is closed by curly brackets. I leave in again another variable name is enclosed within the curly brackets, so that when you print, you want to achieve the same result as this. We'll see that the two results are the same. String escape sequences. We're going to look at the new line escape sequence denoted by \n. This makes it possible to print the string to a new line. So we use the print function to demonstrate this. I want to have some, then we have the new line escape sequence, coffee tonight. So our result is I want to have then the new line escape sequence printed the coffee tonight to the new line. If you want a tab within a string, use the tab escape sequence, which is \t. So we use the print function. We want to have some, then we put a tab escape sequence, and when we print the result to the screen, there we go, we have a tab. Then next we look at how we can print special characters within a string. In this case, we want to insert a quotation mark. So we have want to print it's me, use the escape sequence, then we have this quotation mark want to insert within the string. So when we hit the enter key, we have introduced the quotation mark here, it's me, by using the special character or escape sequence. The string type, I have a special string job interview question. The question is, what do you call a word, sentence, phrase, or even number that reads the same backwards or forward? Number 2, write a program to reverse a string writer. The word writer is a palindrome. That means that it can read the same backward or forward. Let's look at the solution to reverse the string. Define a string called string1 and assign the value of writer. To just show that we can reverse the string, we just introduce another variable string2. So to achieve this in Python, we use the two colons and a -1. We want to reverse this string called string1. When we print this to the screen, we're going to see the result. So we're printing this. So you see that writer is reversed. Try to print the same for string2. Just print, do the same as I did with this resmi string, and try to print string2 and see if the string will be reversed. The none type, we're talking about a special value which represents nothing or no value. We're going to look at 4 situations where we can apply the none type. We can declare the none type by using the none void as a value for this variable called middle name. So we just assign the value of none, print see the value of this variable called middle name, see that the value is none, then verify the type by using the type function of this variable called middle name. So the type is none type. Let's also look at situations where we can apply the none type. And the first situation is when we use the none type as a placeholder. We're going to define a list, like want to go shopping. We don't know what we want to buy yet, but when we reach say the supermarket, start inserting the things we want to buy. So let's declare a list of items we want to buy. As you can see, we'll come up with a list called shopping list. We put placeholder code none, here another none. Then here we remember, okay, we want to buy the keyboard, so we put keyboard there. Then the fourth item we want to buy, we're not sure. Then when we're at the market, we start inserting the values. So the first value we insert, we can use indexing. So index 0, we insert pen. So I want pen to be at index 0. Then at index number 1, we insert mouse. So it's 0, 1, 2, 3. So we need to insert another item at index number 3. Then index number 3, we insert we want to a beggar print or list. List with inserted values will look like. So we have a pen which was inserted at index number 0, then mouse which was inserted at index number 1 there. Then the keyboard remains the same, then beggar at the index number 3. In the second situation where you can use the none type, is when you want to initialize variables that you want to set later. Imagine you have people lining up to enter the cinema and then don't know their ages. The variable called age, you assign the value of none, so that as they come in, start asking how old they are. So here age, so here we have converting. Remember, the input function always returns the string, so if you want to get the number, you always use the int function. So ask how old are you. So this is now when you want to capture the value. When you ask how old the person is, and the person enters the age, here you enter 23. Let's just enter the age and print it to the screen. So this is another situation where you can use none to just initialize a variable, and then later on you set the value. Let's look at a third situation where none is applicable. We're going to define a function called say hi, and we pass an argument greeting. We are going to learn about functions later. I'll just want to demonstrate the none and its use. So we define our function, and then we have a column and ident the code. Very important, identifying the code. Then we have an argument where we want to pass the value. Then we want to output the value of pass to this argument called greeting. So this is the value of pass, and we're attempting to output this by using the print function. Let's use the print function. So when we hit the print, I'm going to run this in the command prompt. I saved my file as a.py, and when I run the code, you can see we have returned none, because a function that does not have a return value implicitly returns none. Yeah, the first situation is when we use none as a default value for the function argument. We start by defining the function called name and pass. We have two arguments: first name and middle name. And middle name, we pass the value none, because this is optional. And then we step by after the colon, we write the code by indenting the code. Then we have an if statement. So I want to print something if it's the middle name. So I want to print the first name and middle name. Else we just want to print the first name. So that when we call the function and pass the value to the argument, our first name, and then this is optional, so we don't have this argument in this function. Let's print to the screen and see the result. I saved my file as b.py, my text file. So I'm running the code using the command prompt, and when I run the code, we print out my first name is John, not a optional argument called middle name. Now let's pass the second argument to a function. I'm going to pass an optional middle name called door. Pass the value to this argument called middle name. Print our result to the screen. You can see that the first part we had my name is John. Now the second time when we print accept the files p.py, it gives us my original name is John Doe. So we've seen that the optional argument we can still pass the value, but initially just had assigned the default value of none. So these are the four situations where none is applicable. The Boolean type is applied in logical operations. This is where the logical AND or NOT is used to produce a Boolean result depending on the combination. The type we're going to look at is the Boolean type. The Boolean type is either a true or false. You can create a program where you expect the answer to be true or false. Boolean values are mainly used in logical operators and conditional statements. There'll be more examples on conditional statements. We are going to learn more about conditional statements. The isInstance function can be used to check the Boolean type. Start by declaring two variables where x is assigned the value of true and y is assigned the value of false. Then we use the isInstance function to find whether x is an int or not. According to our output, x is an integer, and note the comment that it's true because the Boolean is a subset of int type. To demonstrate the Boolean type, let's come up with a simple system. This system will allow access to the building if you enter the correct ID. So we have defined a variable called correct ID and assigned a string value of 1, 2, 3, and we're accepting user input. Then we're going to compare what the user has entered to the correct password. If the two match, we're going to print the message access granted, else we'll print access denied. I've saved the file in C, and the name of the file is that's id.py. That's a Python extension. So when I run the system first time to ask me to enter the ID, I enter the wrong ID and I get access denied because I entered the wrong ID, which is not equal to the 1, 2, 3. And then when I run again the program, hit enter, so enter the correct ID, you get a message access granted because we entered the correct ID, which is the same as what we have in the system. So it's just a simple demonstration of the Boolean. Lists are defined using square brackets, and items belonging to the list are separated by commas. What to know about lists? Ordered. Items are arranged in a specific order. They are mutable. You can change, add, or remove items in a list. Can have jailbreakers. Same value can appear multiple times. Can store different data types, so you can have numbers, strings, or booleans within a list. We declare a list, my list, and we've enclosed the list items within square brackets separated by commas. So this is our output to the printed list. As mentioned earlier, that lists can hold different types. So this list definition has some integer here 2 and the float 0.9, and then it has some strings. We can print it out to the screen also. According to our type function, this is a list. Just trying to verify that what we have is a list. Elements belonging to a list can be accessed by indexing, just like tuples. We're going to learn about tuples after this section. The first element in a list has an index number 0. So here we define some list elements using this variable odd number list. I want to access an element on index number 2. So this is 0, 1, 2, 5. So there we have 5. One of the properties of lists is that lists are mutable, and that means you can change, add, or remove items in a list. We have this list we've defined, and we're trying to define a list of even numbers. So we have 2, 4, and 7 is not an even number. Then we have 8, 10, and then want to change this value so that we can only have even numbers. We can use indexing to change the value to 6. So index number 2, we assign a value of 6, and this is 0, 1, 2. So when we do that and print the results, so we print even number list, or new even number list is 2, 4, 6, 8, 10, and this gives us our even numbers we are looking for. We can add an element to a list. First, we define our list called color list with colors orange, black, and blue. To add element to the list, we use the append method, and the element we want to add is enclosed within the parentheses. In this case, we want to add an element called yellow, and the append method will add an element to the end of the list. So when we run the code, so let's print our new color list. So you see that our new color list now will use orange, black, blue, and we appended the yellow, which is appended at the end of the list. We can also insert an element into a list by using the insert method. The insert method will add an element at a specific index. So in this case, want to insert green at index number 3. So when print, we're going to have index 0, 1, 2, 3. So we inserted green at index number 3. So the insert method adds an element at a specified index position. And another way we can modify list elements by using the remove method and the pop method. The remove method removes the first occurrence of an item, while the pop method removes and returns an item by default last item. So we look at an example. We define list of numbers 1, 2, 3, 4, 5, and then we want to apply the methods we've talked about. Let's start by applying the remove method and see what we can come up with. So we have these numbers 1, 2, 3, 4, 5. So when we want to remove the 2, when we print, so as you can see, we have a 2 here, or index number 1, and index number 5. Let's count 0, 1, 2, 3, 4, 5, and index number 5 will also have a 2. Remove method will remove the first occurrence of an item, meaning this first 2 is one that is being removed here. You can also use the pop method to remove an item. In this case, we want to remove an item at index number 1, in this case 0, 1. So we're removing this item, which is 3, and when we print our new list, we're going to see that 3 is missing because we removed it using the pop method. So lists can be sorted. Let's define our list to sort. As you can see, this list is not sorted. So to sort this list, we get the variable name and then we put the dot and the sort method and print this list. So our sorted list is 1, 2, 3, 4, 5, 6. In the previous session, we looked at Python lists, and this time we're going to look at a tuple data type. Why you need tuples? So we're looking at objects that will not change. When you want to use an alternative to lists, you can use tuples because they're more efficient and fast. They're also safer because no one can accidentally change the values. Creating tuples. You can create tuple of things that do not change. It's actually better when you do it like that. And in this case, we have a month tuple. We'll have January, February, March. Each element is separated by commas and then closed by parentheses. This is a string at a tuple. We have declared some strings within the tuple, so we have these single quotes. We are also going to use double quotes, so just show that you can declare the tuple using double quotes. Here we can declare an empty tuple, just with parentheses, no element. That's an empty tuple. The tuple we have here is called call it mixed type tuple because we have an integer, and then the strings within the tuple enclosed. We have here double quotes. You can use double quotes or single quotes, in this case separated by commas, and there we have a float, so a tuple can have mixed type. Let's output the empty tuple by using the print function. And when you hit the enter key, we just get parentheses because this is an empty tuple. We can also verify that it's a tuple by using the type function, and when we hit enter key, for sure it's a tuple. We print the month tuple also, and after printing the month tuple, we can also verify the type. There we go, it's a type tuple. This is how you can create a tuple. We can create a single element tuple by using a trailing comma, a tuple, and the sign variable. We have this tuple. When we have a trailing comma like this is a single element tuple. We try to find out the type for this declaration. It's a tuple, and then we can even print to just get our result. And what happens when you try something like this? We call this variable tuple2, and then we don't put a trailing comma. It's like this is just a string enclosed in parentheses. As you can see, when you try to print the type, it says type string. Even when you try it this way, where we have this variable called tuple3 and enclose an integer within without a trailing comma, when you print the type, this is an integer because it's input a trailing comma. But this is a tuple. Successfully created two tuples, a tuple with a trailing comma, single element tuple, and this tuple here, tuple 4, with a trailing comma. Make sure you don't leave out the trailing comma when creating a single element tuple. Just like strings, lists, tuples can be accessed by indexing, where the first position is represented by 0. So we have defined mixed tuple. As usual, here we have a string, another string, and then here we have an integer. So on these strings, so this is a declaration of a mixed type tuple. Go ahead and access what's on index 4. The result is beggars. Let's just verify 0, 1, 2, 3, 4. So they are all verified. Let's try to
access what's on index 0, here we have I, which is here because we start counting from 0. So this is how you can access tuples by indexing. We look at tuple slicing. Tuples can be sliced just like strings and lists. Tuple slicing is where you retrieve a substring. So we have defined a tuple called mixed tuple. Can eat two values at once, and let's try to demonstrate tuple slicing. There's square brackets, and then from first index to the end. So in this case, we want to retrieve substring or everything from the first position to the end. And when we print, our result will be that the entire tuple we declared here can eat two values at once. Let's try another example. In this example, we try to retrieve a substring from index number 3 to index number 6. So 0, 1, 2, 3. So this is 3, 4, 5, 6. So let's print and see the result. Here we have two values at once. Retrieved everything from index position number 3 to 6. Then we try one more example. And this example, trying to retrieve everything from the beginning of the tuple, that's position 0 to index number 2. So I can eat, so from 0 to 0, 1, 2. So here we go, that's our result here. I can eat. We look at tuple packing and unpacking. This is when you pack values into a tuple and later unpack them into variables. Let's look at an example. You've declared a tuple called person, and we have assigned a string, John, Doe, and 6.1. To pack this tuple, we introduce these variables that will assign to or declared tuple. Here we separate each variable by a comma here, and then when we try to print, just to verify what we unpacked. So here first name is John and print last name. There is Doe and then hide. And to unpack this tuple, so the first name is assigned this variable John, last name variable is assigned this variable Doe, and they hide assigned 6.1 according to our results. That's how you can unpack the tuple.
Let's look at two methods, the count and the index methods. The count method counts the number of occurrences of a given value in a tuple, just like we saw when we were dealing with lists. Index method gives the index position of the value in a tuple. We demonstrate this by declaring a tuple and want to count the number of times 0.3 appears in this tuple. So here we have 1, 2, 3, and 4. So when we print, 0.3s appear 4 times in this tuple. Then we use the index method, which gives the index position of a value in a tuple. So what's the position of 4 in this tuple? 2. Verify 0, 1, 2. Now we're going to discuss the set data type. It's a Python built-in type which contains an ordered list of unique elements, and two types: a mutable set, frozen set, which is immutable. What we need to know about sets: the elements in the set are unordered, that means they do not have a fixed position, and the set type gets rid of duplicates to automatically have unique elements. The set type allows removing and deleting elements that are mutable. Sets are heterogeneous, meaning they can contain different types of elements, like string, float. To declare the set and see some examples. We're going to look at the mutable set. This is the mostly or widely used type of sets. It means you can add and remove elements, and no duplication is allowed. It is unordered. That means elements are not arranged in a specified order, as we saw earlier on. For this type of set, which is the mutable set, slicing and indexing is not supported. Let's look at examples on how to declare a set. This set, we're going to use the set function to create a set. Then we're going to also create the set using the other method. In this method, we have the set function, which we have parentheses, and the elements are enclosed within the parentheses, separated by the commas. So a variable is a set. So we're dealing with the mutable set where we can add an element. So want to add guava to these elements. Let's add a guava and print the results. And when we print all results, we've added guava by using the add function. And we saw that sets are mutable, so we can remove an element from the set. So we want to remove an element called apple from this set. Print the result and see there, after printing, apple is missing. We've removed apple from the set, so sets are mutable. Let's create a mutable set using the curly brackets. In the first example, we created a set using the set function. So we define set. I will have this variable called a set and use the curly brackets and these integers within the set, where we separate the elements with comma. They want to add an element to our set. So we want to add a 1. So when we add a 1 and print the result, the outcome is, as you can see, sets are unordered. They're not in specified orders. See the order, they're not in the same order as the declaration. We can also remove an element from a mutable set. In this example, we want to remove a 9 from this mutable set. Print the result. You see that 9 is missing because we've used the remove function to remove a 9. Sets are heterogeneous, meaning that they can contain different types of elements. Let's define a set with mixed types. So in this definition, we say we have a variable called mixed set where we have a string. So this is character, a string, and then we have an integer and another string. Let's print our declaration. Then we can also create the same set using the set method as demonstrated earlier. On the print, we get similar result, but as you can see, sets are unordered, meaning the elements in a set are unordered, which means they do not occupy a fixed position. You see the way they are ordered here, where they are ordered, and the order here is totally different. So I wanted you to note that sets unordered, and when we try to check the type, it says the set type. The update method make it possible to add multiple elements to the set. So we declare our set with a variable name called my set, where we have those values 2, 4, 6, 8, 10. We want to add multiple elements. In this case, we are using the update method to add 1, 3, 5, 7, 9 to our declaration. Because here's our outcome. We've added these multiple elements to our set. We can perform a few operations such as union, intersection, difference, and symmetric within the set. So we declare two sets. We have A, which is equal to 1, 2, 3, 4, and B, which is assigned values 3, 7, 5, 6, and 1. Let's demonstrate the symmetric difference. To do that, we use the symbol. So that's how we get the symmetric difference. So symmetric difference is 2, 4, 5, 6, 7. Then we can also find the difference. The difference is when we print is so result 2 and 4. So this is how you find the difference within the set. Then you can also find the union or union. So the symbol we use for the union. So everything in A and everything in B, that's our result. That's the union. You can also find our intersection, what is common between A and B. So intersection is 1 and 3. 1 is common. There's 1 there, there's a 3, there's a 3 there, and there's a 3. So these are some simple examples on set operations.
Let's look at the dictionary in Python. This is where each item is a key value pair. We'll see when we look at an example. And keys must be unique. Values can be of any type, that is numbers, strings, lists, even other dictionaries. It's great for storing and accessing data that has a clear label. We'll see when we look at an example. Here we are creating a dictionary called person, and to create a dictionary we use curly brackets, and then the key value pair we're talking about. This is the key name, and the value is John. This is another key, urge, and the value is 35. This is an int, and this is the key of city, and the value is Chicago. So when you're creating a key value pair, you have colon in between the key value pair. So there the colon, there the colon. So this is how you create a dictionary. We want to access a value of the dictionary. So to access our dictionary, our dictionary is person, and the key is name. So when we print to a screen, our value is John. You can add a new key value pair to our dictionary. We are going to add a new key called title and a new value called Mr. So this is a key value pair to our person dictionary. Let's print our dictionary, or how it will look like after we've added the new key value pair, which is title and Mr. So here we have a new key value pair, which is the key title, and this is the value Mr. We can delete a key. We use the word del to delete a key of the dictionary, the name of the dictionary, then what you want to delete. In this case, we want to delete title, so that when we print a new dictionary, it will look like this, where our key has been moved, including its value. So here we had title, which was a key, and the value was Mr. So when we delete, the title is missing and key is missing. We're going to look at for loops later, but I just want to demonstrate that you can loop through the key value pairs using the for loop. We declared our dictionary called person. So we want to print the key value pairs. So for each key value pair in our person dictionary, let's print the key value pairs. So when you hit print, it gives us a key and a value, key and a value, city, Chicago, print, dictionary, and loop through using the for loop. Let's look at a real life analogy. The school library. Imagine I'm entering the library with different shelves, and each shelf has a label. In this case, the library is our dictionary. Then the label on the shelf is the key. Then the books on the shelves are the values. Let's create a dictionary to depict this example. So we create our math label and the box on the shelf within our library dictionary. We create another label called science, and the books on that shelf are physics, chemistry. We carry on to create another label called sports, and the books on that shelf are soccer, golf, and tennis. So we create a dictionary enclosed in curly brackets, and each dictionary key value pair is separated by a comma. So to access the math books within our library, we'll look at the label of the shelf. In this library, we're looking at the math label, and we want to access math books. So when we go to this shelf, we're going to see that we have algebra, calculus, and trigonometry books. You can even verify the type by using the type function. So we created a dictionary. Let's look at dictionary methods. We're going to use the dictionary we created area called library to demonstrate this. The first method we're going to look at is the get method, which returns the value for the specified key. If the key is not found, returns default or none if not specified. In this case, our specified key is sports. Want the values. Let's print and see the results. So the values for this specified key, soccer, tennis, golf. So according to this key value pair. What if we try to retrieve the values for a key which is non-existent? So this key is not part of our dictionary. And when we try to print, the result is none, because if the key is not found, returns default or none. Another method we're looking at is the keys method, which returns a view object of all keys. So let's output all the keys related to this dictionary called library. So when we print, you're going to see that we have the math key, science key, and sports key according to our dictionary declaration here. Then the third method is the values method, which will allow us to output all the values of our dictionary. So for the values methods, our library.values, when we print to the screen, the output. So output shows all the values within our dictionary from the key value pair of math, where we have algebra, calculus, trigonometry, to the key value pair of sports, where we have soccer, tennis. All the values have been printed by using the values method. In your free time, try to run the items method, which returns a view object of key value pairs as tuples. Try that in your own time. The fifth method we are looking at is update method, which updates the dictionary with elements from another dictionary or iterable key value pairs. Let's have an example. So here, we want to update our dictionary with our new key value pair. So key is the religion and the values are religion, Hindu, or Muslim. So when we print our dictionary, you're going to see that we have updated our dictionary with a new key value pair. Our sixth method is the pop method, which removes the specified key and returns the value. Let's look at the pop method where we assign the value to region key, so that when we just print, we'll look at these values. But when we print the dictionary, let's look at the result because of using the pop method. So because we use the pop method, you're going to see that the key value pair is missing for the region where we have the values Christian, Hindu, and Muslim. In your free time, try this seventh method, the pop item method, which removes and returns the last inserted key value pair. We look at the eighth method called the clear method, which removes all items from the dictionary. What do we get? We get an empty dictionary because we cleared. Removes all items from the dictionary. In this session, we're going to look at the if statements. We're going to declare a variable called number and assign a value of 10. So to start the if statement, you use the lowercase if, and then the condition, in our case, is the number less than 9, and then the colon. Everything below here after an indent is what's supposed to execute if the condition is met. Here we assigned the value of 10 to the number. Is it number less than 9? Do we expect the code to execute? Let's see. The code did not execute because the condition is not met. There's nothing output here. So let's try another example. We'll introduce the else statement so that if this condition is not met, we want something to be executed. So this is our else statement. After the else, also have to make sure that there's an indent after the code. So the if and the else have to align. So this is what we expect to execute. Let's run the code. So when you run the code, but I can execute if condition is not met. So we have this part of the code being executed because in the first case the condition was not met. Number which has been assigned the value of 10 is not less than 9, so this could not execute. But since this could not execute, went to the else statement where we have to print out but I can execute if condition is not met in this statement. So you can use the else to execute what you want to show if the condition is not met. You can add more conditions if you use the elif, which is an else if. So again, we come up with a simple if else statement where we have this condition. If number is greater than 10, print number is greater than 10. Else if elif, which is else if number is greater than 5, print number is greater than 5. Let's also include an else statement. Then the else statement has been included, which will execute if both of these conditions are not met. So let's run the program. The output is number is greater than 5 because this condition is met, or number here, which is 10, is actually greater than 5, so we have this statement being printed to the screen. Let's try more examples to demonstrate the else if statement. In this example, we look at a simple grading system where the user enters the mark, and then based on the mark, we show the grade. We are converting the input to float because whatever the input function returns is a string. Start by capturing the mark from the user. So here the user enters 78.5. we code using the if statement. If mark is equal to or greater than 85, want to award grade A. Then else if mark is greater than or equal to 80, want to award grade B. Let's add more else statements. Else if mark is greater than or equal to 75, we want to award grade C. Another statement, else if mark is greater than or equal to 70, we want to award a grade D. Then we include the else part when none of these conditions are met. So when we run, we get grade C because what was entered, which is a mark of 78.5, matches this condition. Else if mark is greater than or equal to 75, the student is awarded a grade of C. So this is how you can enter multiple conditions using the elif or else if. Let's have another example. We can combine logical operators and comparison operators within the if statement. So let's develop a system to allow employees to have access to the work premises. They can only have access between 6 a.m. and 5 p.m. and employees must provide the correct ID to access the gate. Here we prompt for the ID from the user. They need to enter the ID. It doesn't matter what they enter, whether they enter a lowercase or uppercase. We want to convert whatever they are going to enter to uppercase by using this method, the upper method. So here the employee is asked to enter the ID. The ID entered by the employee is imp123, which is already lowercase. We're going to see once we code the program. Let's code the program. Also want to allow the employee to enter the current hour, so we're capturing the hour they've arrived at the work premises. So let's capture the input from the employee here. So the employee has entered 9. So for our system, we want we have an if statement which checks if the correct ID is equal to this predefined ID, which is uppercase. It's a string uppercase EMP123, and this is a logical operator, and want this condition to be met. And then here we enclose everything because we want this to execute. Then we have these two conditions. This condition has to be met and this condition has to be met. So both conditions have to be true. If the correct ID is this one, and the current hour lies between 8 and 17, we want to grant access. Else we want to deny access. We run the code. What's the output? So the output is access granted, because if you look at the user input, which is imp123, which matches our predefined ID here. And this ID, why does it match? Because this one's converted to uppercase by this method. That's why this ID that was entered by the user matches our predefined ID. So this is how you can also use logic operators and comparison operators within the if statement. Let's look at the if statement. This program, I'm going to use the command prompt to run the program and a text editor to code. I'm not going to use the editor. Of my choice is the Notepad++. I'm going to open this as an administrator to demonstrate the nested if statement. So the file name, I've given it demo.py. I've saved it in C. When is it best to use the nested if statements? If you want to check condition, only if another condition is true. This will allow you to avoid checking conditions that do not need to be checked. So for this example, we are coming up with a simple login system where we capture the username from the user, and we convert whatever input is going to be captured to lowercase. And then also want to capture the password that's going to be entered by the user. So for our if statement, we have this predefined a user name which is equal to admin, lowercase, it's a string, and then here we have a colon so that we write the statement to be executed by this if statement. This is how you will do the nested if statement. So the first if statement, which you want it to be true, and want to check if another condition is true. So we have a nested if statement by indenting the code. So according to our not yet check a condition only if another condition is true. A condition is true and another condition is true, we want to allow access to our system. Now for this part, the if part has its own else. If this condition is not true, we want to print something on the else part here, else statement. So here we're talking about the password. If the password is equal to 2468, we want to allow access to our system, else print incorrect password. So if this condition is not met, we are going to print incorrect password. Then we go out to our outer if statement, where we check if the username that was entered by the user is equal to admin, the string admin. So this if is aligned with this else, so want to print something if this condition is not met. So want to print username is not correct because we are dealing with the username here. So let's save our program and run the command prompt as an administrator. So we're able to see the code and the command prompt on this side. After running our program, username entered is admin, which is the correct username, and the password is wrong, which is the wrong password because our predefined password is 2468. And let's run and see what the output will be. So our system produces this output incorrect password, which is coming from this part of the code because our password is 246 and the else statement is printed for the incorrect password. Okay, for this next time we run the system. So again in C we type demo.py. Again we run the system so that it will allow us to enter the username, which is the wrong username, and enter password, which is the correct. This time we've entered the wrong username and the correct password. We want to see the output. So the output is username is not correct. So here where we define the username of admin, and if this is not correct, we got the else, what will be printed, username is not correct. Okay, this time we run our system again, demo.py, and here we capture the right credentials. We enter the right username and the right password. So when we run, we see that our output login successful because both our conditions have been met. Outer if statement, a condition is met, and the inner if statement, a condition is met, and therefore we have our successful login. So this is how you can do a nested if statement. In this session, we're going to look at the for loop. The for loop is used to repeat a block of code a number of times, and it can be used to go through data types such as strings, lists, or in a sequence. We'll look at an example. In our example, first we declare a list of colors. To start the for loop, you start with the keyword for, and here we're saying for each value of color, loop through these values. What we're going to do, let's introduce a print function to demonstrate that. So here we're going to print each value of color, so this list. So the first time we loop, we're going to print black, then we're going to loop back, we find another item, we print white, we loop back, find another item, we print green, loop back until we print our last item, orange, to the screen, so that when we print, our result is black, white, green, orange. In this example, this was an example when you are talking about strings where I had to print a string called go. When we use the multiplication symbol and multiplied by 4, so that we print this 4 times to the screen. We're going to demonstrate this by using the for loop. In our example, when we printed to the screen, it got the result go, 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 go. We just use the print function, print by 4. How can we do this using the for loop? We're going to introduce what is called the range. You can use what is called range with the for loop, because the range will help us to print something a number of times. So we want to repeat an output a number of times. So we're starting our loop. So for in range, so meaning you want to repeat an output a number of times whenever you use the range method. We don't include the actual value 4. So we'll start from 0, 1, 2, 3. So let's print this so that we see what we're talking about. Repeat this above example here, which was done using the print function, but want to do it using the for loop. So we're saying let's repeat this 4 times. When we hit enter, we get a similar result as what was printed using the print function here. So here we looped of 4 times. So the first loop was 0, 1, 2, 3. An example of using a range method. In this case, we have a range of values. We want to print some values from 10 to 20. When you define your range as such, we don't include the last value. So start from 10, we end at 20. So let's try to run some code so that we see what happens when we use the range method in this manner. So we want to print, we loop through starting from, in this case our initial value is 10. When we loop through first time, print a 10, the second time to print an 11, so to continue printing until it hits 20. So when we run our code, so that's our output to the screen, demonstrating how you can print a range of values using the range. You just define your starting point and the comma, and then ending point, but remember the last this value is not included. In this example, we're going to look at the nested for loop. So the for loop can be nested, meaning you have an outer for loop, then ident the code to have an inner for loop. In this example, what we have is our range. When you have a 3 within the range method, we start counting from 0, 1, 2, loop 3 times. In this case, when we hit 0, the first value will have to loop again through these characters. How many characters do we have here? We have 3 characters. We have the P, I, and E. So the outer loop will come with a number 0, which is the initial value, and loop 3 times. Okay, to demonstrate our output, so we introduce the print function where we get the initial value, which was 0. We loop then through the inner for loop 3 times because we have 3 characters. So it will be 0p and 0 and I and 0 and e. Then we're going to loop out again to get the next value, which is a 1. So it will be also the 1 will have to loop 3 times because we have 3 characters. So it will be 1 and P, 1 and I, 1 and E. So to just demonstrate that, let's just have an output to the screen. So the first output was a 0, that loop through the inner loop 3 times to assign. So we have a 0 on P, 0 on I, 0 on E. Then I had to loop out to get the next value, which was a 1. So the 1 again had to loop 3 because of 3 characters here. So 1 on P, 1 on I, 1 on E. Then it went to the last value, which was a 2. So we have had to loop 3 times through the inner loop. So those 2 and P, 2 I, 2 E. For these nested for loops, they grow very fast. So just be aware of that because this loop can grow fast depending on the range you have within the loop. So this is one example of a nested for loop. Well, let's look at another interesting example. In this example, I'm going to use Notepad++ to run Python code through the command prompt, and the name I've given it list.py. I'm avoiding to use the idle Python compiler because with the idle, when you want to use like input function or print function, as you code, it keeps printing. I want to run the entire code at the same time using text editor via the command prompt. I'll demonstrate another nested for loop example where I want to print the x and y coordinates using 2 for loops, an outer for loop and an inner for loop. So to start with, I declare an empty list so that whatever I'm going to generate using the for loop and the range function will be stored within our list here. So start our for loop, and then you want to loop 3 times, starting from 0 up to 2. So our x coordinates will be represented by 0, 1, 2. And then for the inner loop, after indenting the code here, our y coordinates will be also represented by 0, 1, 2, and append the coordinates to the list here. The append method adds the item at the end of the list. So the 0 will loop through into the inner for loop where we're going to find another 0 to loop 3 times before we loop out with our first outer loop count. So it will be 0, 0, 0, then 0, 1 and 0, 2. And after the 0 is done, we loop out to get 1. Then the 1 will loop 3 times to be 1 and 0, or 1 and 1, 1, 2. Then we loop out to go grab the 2 from the outer loop. So we come with the 2. Then we loop 3 times so that we get our 2 and 0, 2, 1, 2, and 2. So let's do that in the code and print to see the results. So here we want to print our results and view for the screen. Then in my command prompt, I'm going to run my Python code, which is saved as list.py, and hit the enter key so that you can see the output. Let's expand the screen to see our output. So I'm expanding the command prompt. Alright, so as you can see, so this is our output where we had to print the x and y coordinates and store results within a list. So this is where I was saying the outer loop when it grabs the 0, it will loop 3 times within the inner loop to grab, so it will be 0 and 0, then 0 and 1, 0 and 2, then to loop back to grab a 1, then after grabbing the 1 from the outer loop, it will grab a 0 from the inner loop, and then a 1 will grab another 1 and then grab a 2. So when this is done, to loop out to the outer loop and grab 2, so it will be 2, 0, 2, 1, and 2 and 2. So this is how nested for loop works. Just be aware that, as I mentioned earlier, when you nest the loops, they tend to grow fast, the for loops, depending on the size of the range. Another important aspect when you are dealing with the for loop, you need to understand how to use the break. So this is when you want to exit the loop, when you find what you are targeting. Let's look at an example. In this example, I'm going to define a list of fruits where I want to target apples, so that I demonstrate how we can use the break within the for loop. So I start my for loop. I want to loop through our list of fruits. Then I introduce an if statement. So it's important to note that you can use decision making within the for loop. So I'm saying if I find a match, which is apples, what do I want to do? So I want to say this is where I exit break. So the way break works, it will the loop will start by hitting oranges to print orange, and then to loop back prints bananas, and then when it hits apples, it won't print the item I'm looking for, because here my item of interest are apples. It will just print this is where I exit. So when you use break will not print your target item. It will print the item just before the target item, so that when you run our code, here we have still looking. I found oranges. So when we looked at the first time, we hit oranges, so we printed this statement, because this is still within the for loop. As you can see, the code block, all these are within the for loop. So we're going to print using the if string. Still looking, I found a fruit, the first fruit orange, then we look back, we hit banana. So when we hit apples, we are not printing I found apples, because that's how the break works. It won't print what you're looking for, but it will exit the loop. Let's look at another important keyword called continue in a for loop. This is used when you want to skip some items without stopping looping. I have declared a list of numbers, and I want to identify odd numbers and even numbers, but I only want to skip some items without stopping and just print what I want to see to the screen. So to achieve this, how can I do that using the for loop? So as usual, we start our for loop for number and numbers. It's a good naming convention when you're dealing with the for loop. use the plural and the singular here. Oh, here we have an if statement within the for loop. So what we're saying is when you write that number, so number mod 2, so from as we loop through these numbers, if we find that the number is odd, that means the remainder is not 0, so we skip that number, but we still continue. So continue, hit the next number, check this number odd. This number is not odd, this number is even. So I won't skip this number. So let's just add more code to see how we can print the even numbers as we skip odd numbers. So after the continue, we want to print to the screen our even numbers. So when we hit our enter key there, our output is in such a way that because of the continue, which allowed us to skip some items without stopping, but went on to print what we're looking for, which are even numbers. So when you're using the continue keyword within a for loop, just know that you want to use it in such a way that you skip some items without stopping looping. As in this example here, we had to skip our odd numbers and then we continued to get our even numbers and print to the screen. Let's look at another example where we use logical operators, that's the AND, OR, and NOT within a for loop, and also with nest and if statement within the for loop. To do that, we come up with a list of items which has a mixed type where we have integers, floats, strings, even a boolean true. Let's write some code. So we're given a list of items above, or identify integers and floats. So let's write some code to do that. So we start by starting our for loop with a for keyword. So I want to loop through items within using the for loop. You want to use the isInstance method, which can help us to identify the data type of this item, but in this case we want to identify, is this item an integer? A piece of code is saying let's identify an item which is an integer and that item is not of type boolean, a bool, so true or false. So exclude true or false, because in Python when you look at true, it's considered an integer like 1, and then when you look at false, it's considered as an integer which is 0. So I want to exclude the bool value so that we only identify integers, then we print the result to the screen. Let's introduce a print function here. So we're only interested in printing item which is an integer. We've excluded the boolean using the AND NOT. So as we learned earlier, an input which is true and true, and will give a true result. But when you use AND NOT, it negates the, if your input was true, it's going to negate it to false. So we are using AND NOT, so we're not interested in the boolean value, only interested in the integer, and then we print that integer to the screen. So we'll repeat a similar piece of code. Else, if that item we're looking for is of float type, we want to print that item to the screen by introducing the print function and say that this is a float. So when we run our piece of code, we've been able to identify all the integers and floats, another float, and an integer. So this is a simple program you can use to identify the floats and integers. Let's do one more example where we have a list of candidates who are supposed to participate in sports, but for a candidate to qualify, we are looking at a certain GPA, so we want to only select candidates who are older than a certain age and who have a grade point average of at least 3.2. We do this by coming up with a dictionary. So this is a dictionary type. So we declare a dictionary. We have a key value pair. So this is a key, and we have within this key is supposed to be a value. A value has also a key and a value, so which has a dictionary within. So it's a dictionary within a dictionary. So I want to use this. Look at it like a mini database. So I want to retrieve these values and identify those candidates who qualify to go for soccer trials. So we'll start a for loop by looking for name. So this name is like a key name, like John, Jane, David, Adam, Mary. Then candidate info, these are the values, so it's key value pair for the dictionary. So candidate info, we're talking about the age and GPA, which is another dictionary here, which is a key value pair. So that's how we start our for loop, and we want to loop through these items. We introduce an inner if statement. So if so candidate information is the age under the GPA. So if we have both of these conditions satisfied, what are we going to do? So we have a age of, we're looking for a person who's older than 17 and whose GPA is at least 3.2. Print their name and their age and also their GPA, that's a grade point average, to the screen. So for this program, we just want to print eligible candidates to the screen. When we run our code, you see that eligible candidates can participate for soccer trials. John, Adam, and Mary. And John is 19 years old with a grade point average of 3.2. So this is how you can do such an example. I wanted to just demonstrate that you can use also the Python dictionary within the for loop to come up with some results. Hello guys, we're going to discuss the while loop. The while loop is used to execute a block of code as long as the condition is true. It's best used when you don't know beforehand how many times you want to loop. We start by using the Boolean true in a while loop. The Boolean true will execute an infinite loop. So to start your while loop, use the while keyword, and then you have your condition. So while this condition is true, 1 to 2, we ask the user how they are. So the program will continue greeting us as long as we don't break out of this loop. So this is means the program will continue running. So here see greeting, but how are you? So the program will continue greeting us. But you want a condition where we break out of this program. So if greeting, this is this lower function converts the uppercase letters to lowercase. So here I have, if I enter capital Q or uppercase Q, to be converted to lowercase q, because I want to introduce a condition here so that if the user enters Q, they break out of the loop. So here I want to say print say by, and then break out of our loop. So let's run the program, demonstrate what I mean by this infinite loop. So we asked, how are you? Good. How are you? Not bad. How are you? Very fine. So this means the program will continue, only break it by introducing the Q. But let me just demonstrate something. If I press a Q with a space, you see the program continue running because here we don't have a space. So the only way to avoid that is by, let's put a strip method here so that we don't allow spaces here. First, let's just type the Q so that we break out of the program. So by, so let's do the same thing. Let me just copy this and just redo it here. So this time I want to prevent someone from typing the Q with a space. So dot strip, so that whatever they enter, whether there's a space or no space. So if here I'll type Q with a space, when I print, say program says by, because of the strip method gets rid of the leading and trailing white space. So this is an introduction to a while loop. Let's look at other examples. Hello guys, in this example I'm going to compare the while loop with the for loop, both counting from 0 to 2. I start with the for loop for I in range. Since I'm counting from 0 to 2, I'll have a range value of 3. So I want to print I. So when I print, I have my count 0, 1, 2. This value is not included, a 3. So we do the same with the while loop. We start by defining a counter and assign a value of 0. So while count is less than 3, want to print count, and then want to increment the count by 1, and then print the result. So what's happening is here we initialize our count ourselves. This is like we're doing the manual way. And we say as long as the value of the count is less than 3, we increment the count. So in this case, everything was done by Python. Everything's automatic. If you have something similar you want to implement, you can either use for some cases while loop. In this example, we want to simulate an ATM machine. We only allow the user to enter the PIN 3 times, and if that PIN is not correct, we block their card. We start by defining our PIN, or right PIN. So our right PIN will be 2, 3, 4, 5, and then we declare the number of attempts we are going to allow, or say start counting from 0, and then using the while loop, or count is less than 3, want to capture the input from the user. That input is the PIN. So let's say, so once the user enters their PIN, so let's say if our PIN matches what was entered by the user, we want to grant access to our ATM. So we print and we break out of our loop because we've achieved our goal. So there's no need of continuing. What if they enter the wrong PIN? Let's introduce an else statement here. So else, so we print a message to the screen, wrong PIN entered. We increment the number of attempts. So we'll count plus equal to 1. So the first time the attempt to enter the PIN or count was 0. Then the second time the attempt to enter the PIN or count will have the value of 1. And then the third time the attempt to enter the PIN or count will have the value of 2. But as you can see here, while count is less than 3, so at this point when count is carrying the value of 2, we will allow them 3 times to try to enter their pin, because we started counting from 0 as our first count, then 1 as our second count, and then 2 as our third count, and this value of 2 is less than 3, so allow them to enter the pin. Introduce an if statement. This if statement will be out of the while loop, so if count reaches 3, print a message to the user. I'll use the command prompt to run this code. So program is called fun.py. So once we run the code, we enter the pin first time, we enter the wrong pin, then we have a wrong pin entered. Enter your pin. This is the second time we are asked to enter the pin. So again, second time we enter the wrong pin, so wrong pin entered, enter your pin. So the third time we enter the wrong pin, what will happen? So wrong pin entered, card is blocked too many attempts. So let's run our program. This time we try to enter the correct pin. So our correct pin was 2, 3, 4, 5. When we enter, so have access granted. This is how you can simulate an ATM machine using a simple program. In this session, we're going to look at functions. A function is a block of reusable code that can be used to perform a specific task. We start by looking at how we can define a function. So we use the keyword def and then space and the name of the function. In case the name of this function is called greetings, then open and close the parenthesis, and within the parenthesis you put what is called a parameter. In this case, the name of this parameter is called name, and then a colon, so that we can start writing our block of code. So this block of code, we want to print the greeting, and then also the name we are going to pass to this parameter. When we do a function call, so we call the function called greetings, the same name as the name we used here, and then parentheses. So here we pass a value. This value is called an argument. We pass a value to a parameter called name here, so that we can print to the screen our greeting. And when we run our code, you see that we have how are you, John? Because John was the value we passed to our parameter. The function is reusable. We can use the same function and also pass a different argument. In this case, John, the same parameter name, and print. So let's run our code and see the output for both calls. So here we have how are you, John? How are you, Jane? Because our first call we passed John, and the second call we passed Jane. Let's go to the next example to demonstrate that you can set default values to parameters. We use the same function as we used function called greetings, and this time we set a default value called guest to this parameter. Then repeat the same code as before. Want to print the greeting to the name we're going to pass, the value we're going to pass to this parameter. And then on first call, we pass a value, an argument called Alice. And then the second call, we don't pass any argument. So when we print our results, so after we run our code, you see that the first call we have how are you, Alice, prints the value we passed. Then for the second call we didn't pass any value, and we have how are you guessed, because we had a default value that was passed to the parameter code name. In this example, we're going to demonstrate that you can pass multiple parameters to a function. Our function definition, the function name is add numbers. So the parameters we have A and B. So I want to perform some basic arithmetic operation result where we assign the sum of A and B to result, and then show our result to the screen. And in this example, so we call a function and pass two values. So for A we pass a value of 12, and for B we pass a value of 8. And when we print, we run our code. Our output will be for the sum according to result where we had assigned the sum of A and B is 20. Let's have another example. In Python, you can pass arguments using parameter names. Like here we have the parameter name, and we pass an argument 12, and there we have a parameter name and pass an argument 18. Just like before, we run the same code, but this time by just using parameter names to pass arguments, we get the same result. In this example, we want to calculate the area of the circle. Have two we have a variable pi with this value, and then another variable radius, the value of 2, and then the area of circle is given by pi r squared, and here exponentiation, using exponentiation meaning radius to the power of 2. And according to this example, the area of this circle will be given by, so we run our code, so it's 12.56. Let's redo the same example using a function. So in this example, this is actually useful when you usually calculate areas of the circle, so you don't have to continue repeating the process. You can just do that by calling the same function. So here we have the function called area of circle, and we pass two parameters, radius, pi, and then we return the whatever the result we're going to get by multiplying here. So pi multiplied by radius squared. We want to print the area of the circle by passing arguments to the area of the circle by using our function. Get this time, since we use different values of 200.96, you can let your function accept a flexible number of arguments. That's our variable number of position arguments, and our function name is add numbers. And to pass position arguments, use an asterisk on the keyword args. This means we don't know how many arguments, position arguments we want to pass. That's why we use the asterisk to initialize the total to 0, because we want to add all the numbers of our position arguments. So I introduced a for loop here because I want to loop through tuples. You see the tuples down there. So for num in arguments, want to loop through each item within the tuple and add it to our total, which was initially 0. So as we loop, we grab an item, we add, the next item we add. Then after adding, we want to return the total. For our first position argument, this is a tuple of items. So we have these items within the tuple. Want to add these numbers and to return the total of this position argument. And in a similar manner, we have another tuple here. We're going to grab each item and add total, so we want to have two totals for this position argument. Our output will be, so for first position argument, the totals is equal to 48, and for second tuple, the total is 1243. So this is an example of how you can accept a flexible number of arguments. In this example, we use keyword arguments. This is used when you don't know how many keywords arguments will be passed. We start by defining a function called show user info, and then to perform a variable number of keywords arguments, you use two asterisks and the keyword quags, and then close everything in parentheses and a colon. And we're going to introduce a for loop, because we're trying to loop through Python dictionary. So for key, a dictionary has a key value pair. So for each key and value within the dictionary, we want to loop through the items. So as we loop through the items, we want to print the results to the screen. So for each key value pair, we want to print the result to the screen. So we call a function and pass the Python dictionary. There's a key and this is a value. There's a key, this is a value. The key is a value. As you saw, we're looping through the key value pair and want to print the results to the screen. When we run our code, you're going to find that the result is output from a dictionary. So we have name Adam, or age 35, country India. Let's have another example where we combine now the quags and args. So in this example, we combine the args and quags. We have a function definition, how to, and then we just want to output the results of the args, and also want to show the keyword arguments results of our quags. But as we do that, we have to use within our function here. So the value, this is a list. A list can have different types. So we have a list within a list, and we have a dictionary within the list. And we want to grab the args, which is the list, and also the quags, which is a dictionary. Hello guys, in this session we are going to look at error handling and how we can handle errors in Python. We start by giving an example where we have two variables, x and y. We assign the value of 8 to x and y, a value of 0 to y. So let's try to divide by 0 and see how we can handle the error. So at this point, you want to divide x by y, so x divided by y, and y is 0. And when you run our program, you see we have this error, zero division error, addition by 0, and our program has crashed. In Python, we can handle such errors by using the try except block, which handles errors gracefully so that our program does not crash. So we do that by using the try keyword and then a colon. So under this try block, it's what we want to do. Like here, we wanted to divide x by y, which is divided by 0. So whenever you have the try block, you put what you want to do. In our case, we want to divide x by y, and then we assign the result answer to the variable called result. Whatever we do under the try block is potentially going to give us an error, and when that error occurs, that's where we introduce the except block. So the except block has the name of the error. So in our case, we had zero division error, so except zero division error, and then we have a colon, and then we ident our code, and then we need to notify the user when the error occurs. So the try block is what is potentially most likely to give an error and what you're trying to do, and then the except block, what you're going to output to the user when that error occurs. So when the error occurs, we want to notify the user. We can even put the name of the error in the print function. You cannot divide by 0. So that when we run our code, you see our code gracefully executes without crashing, just gives an error. As row division error, you cannot divide by 0. So this error occurs when you try to divide a number by 0. In this second example, we define a list called mylist with we have 3 integers 1, 5, 7. Access an element on index position 3. So remember, when you're dealing with lists, it starts counting from 0, so 0, 1, 2. So we don't have an element index position number 3. When you run the program, we get an error, index error. So to handle this error gracefully in Python, we start with a try block. Then what we are trying to achieve, we are trying to access an element at index position number 3. And then in case an error occurs, we need to introduce the except block and the name of the error and what we are going to output when the error occurs, so that our program can run gracefully. And this is the message that will be output to the user when that error occurs and try to access an index that does not exist. So to correct that, we can even access an index number 2, because we know in this case this index exists. So index number position 2 is 0, 1, 2. So we've been able to access our element 7, the index position 2. So this error occurs when you're trying to access index position which does not exist. Hello guys, in this presentation we're going to look at the import statement. The import statement is used to access external code such as modules or packages. We can use functions, classes and variables within the module, and it helps to reuse functionality without rewriting the code. We'll look at how you can import an entire module. So in this example, we use the keyword import, and then the module we want to import the math module, so that we can use the functionalities within the mathematics, this math module. Once the module is imported, you can use the log function, the logarithm of 100 to the base of 10, and then you can calculate the result, which is 2. You can also use the math.py. So we are using this functionality. You want to use pi, which is 3.14, etc., etc. You can also, after importing the module, you can also use the ceil function, rounds up to the next integer, which is 4. You can also use the floor, which rounds down to the integer here. So we have 5.7, so rounding down just to print 5. Then the factorial, it even starts from 0 factorial. 0 factorial is equal to 1, so it starts from 1 times 2 times 3 times 4, then it gives you the value of that given number. Then apart from that, you can also calculate the power by using the math module here. You can call this function 3 to the power of 3 and then print the result. Apart from importing the entire module, you can import what you need from a module. Like in this case, say we want the square root of a number, we can just from math import sqrt. So it's like want to calculate the square root of the number. So we use the from word, and then the module want to get the functionality from, then the import keyword and the specific functionality we want from the module. So here we're interested in importing the module that can give us the square root of a number, so that when we type and print to the screen, see that the square root of 25 is 5. So we've looked at two aspects, importing the entire module and importing a specific function from the module. In this example, we're going to look at how you can import multiple modules. To import multiple modules, use the keyword or from, and then the module you're importing from. In this case, the math module. We want to import a square root function and the ceiling function. Once we import multiple modules, then we can use them in our code. So like to calculate the square root of, say, 4, can print the square root of 4, then it's a ceiling function which rounds the number up, like in this case 9.8, which gives us 10. We're going to look at how you can create your own module and import it. Like in this case, I create two functions to calculate the sum and another function to calculate the difference. And then I want to import these. I've saved these files as m.py. Can create another file where I can call this function. So this is the file I've created. So in this case, I want to import everything from my module. So the name of my module is it was m.py, a Python file. So I want to import everything. Right now the code is commented out. I haven't imported anything, but I want to import everything so that I print this to the screen using another file. Both files should be in the same directory. So I'm calling the function to calculate the difference, and here I'm calling the function to calculate the sum, so that when we and comment out the code here, I can comment out the code, so that now I've imported everything from the module. Actually, this is not recommended to import everything. It's better you import what you're looking for in the module, specific functionality. Then run our code. So this file we have called my module is called sq.py. So you can see, so I've called both of my functionalities from this module m.py. So I can calculate the difference, which is the answer is this one, and then I can calculate the sum, which is this one. Then apart from just importing everything from within a module, you can do this even with the math module by importing everything. As I said, it's not recommended to do that. You can also just import one thing, like in this case, you just want to import the difference module, so that, okay, I didn't save the file. Let me save the file so that we just import the module to calculate the difference. So as you can see here. And then the other thing I want to mention is that you can import multiple modules of your own. This is your own module. You can also import multiple modules, like they are importing both functions from the module called m. And then I want to print clear the screen. I want to print the results. You can see that once I import multiple functionalities. So after importing multiple modules from the module you created, let's talk about what a data frame is before we do our next project. A data frame is a two-dimensional tabular data structure, mainly used in data analysis. So the pandas library is what we're going to use to create our data frames. We start by importing our pandas library. PDs, that's an alias. Then we can create our data frame by calling it data. So this is just what we have is a Python dictionary. We haven't created a data frame yet. We are just coming up with a key, a code name, and then the value for this key. This is a list, as you can see, of names. So we come up with a list of names there, and then age, another key, and a list of ages for 1, 2, 3, 4, 5 individuals. Then we also a list of status. So once we come up with the list, this is now where we create a data frame. So when creating a data frame, first we have these keys, we have these values. So each of these keys is going to be a column name, and all the values will be the values within the columns. Then at this point, we are converting the dictionary into a pandas data frame, alias PD here. If we didn't use the alias, we're going to use pandas. Instead of putting PD, we're going to use pandas, but since we use the alias, we put PD. Then I can print the result to the screen. So that's our created data frame. The index numbers from 0 to 4 for each record. We can update our data frame. This is how we can do that. Yes, we realize that we left out a column name, but wage, we can do this by updating. So you can update that column and with the values. So by just using our df, so this is what we're trying to insert as a column and the values for that particular column. So that when we come and print our data frame, what you're going to get will be, as you say, print df, so we get this result. So we can also adjust everyone's wage by 100. This is how we do it when we're dealing with the data frame. So we print the new wage, we just add 100. So we have this data frame where I want to increment the wage. The column name is wage, and then want this wage data frame to increment. This is a float value. We add 100 to that. Then we print the new data frame, then incremented wage. As you can see, here we had 1, 2, it has come to 1, 3, and there we have 1, 2, 50, it has come to 1, 3. So 100 has been increased across the board.